Hey everybody, this is the SIG testing meeting for 27th of March, and the document meeting notes and agenda is linked in the group chat. If you have something you want to add to it, just go ahead and put it in there right now. The first thing we've got today is conversation on generating API usage and compliance documentation. So you've got the floor.
Thanks, this is Chris. Can you hear me okay?
Yep, your audio is coming across well.
Awesome. So one of the things that the conformance team has been looking for is increasing the usage. On the last, it was a conformance meeting before last, Dan Conard allocated 25K for a couple developers to go through and start writing our test to bring it up to 100% coverage. But I was trying to prioritize those. Might be a good idea on what we're actually using with our add-ons, and obviously it would also help with our API coverage to have a what are we covering from a percentage. And so I looked at some logs. I think we have some things we're looking at the log output from different tools, but it felt more complete if we were to put something like a man-in-the-middle proxy and record all of those calls at a RESTful level and compare them to our API and Swagger definitions. We took a little bit of time to try to get a proof of concept together for the MITM injections. It's based on some other work that uses an initializer that modifies IP tables, and we do a CSR request to the Kubernetes CA that is has the same CNAMEs and as the API server, and we put that in front of the API proxy. And then currently we're setting IP tables rules in the initializer for the destination of the API server using the environment variables. Forget exactly which ones. But I just wanted to get some feedback. Are there better approaches to getting a better CA or routing, or is there maybe better ways overall for us to get better coverage? Yeah, that's it.
So I guess my first thought was, what's the win here over just looking at the log files?
So right now we're running a tool on the output of the E2E tests. That's what we have. And what I'm suggesting is specifically targeting the add-ons. So when we have an add-on of a different language coming up and it's doing API calls to the API server, we'll be able to tell, are those API calls formatted correctly on the wire? Are they an alpha or a beta or a stable, and generating the coverage? There are some instances, I guess, in the Google and the GKE where we don't actually have access to all the logs from the API server.
Yeah, I mean, I've reviewed the code that currently looks through the logs, and I guess being able to validate the format of incoming requests from add-ons seems like a pretty useful thing. But as far as using this to drive API coverage numbers, I'm not, like, if parsing the log isn't missing anything, I'm not sure that, well, I'm not making any call, but like, just my first blush impression is like, this seems like, you know, if we're missing something with the log approach, this seems valuable, but otherwise, I'm not sure like where it fits in.
Yeah, is it for the Kubernetes add-ons in particular? Do we have a way to see what APIs they're covering easily within this test? Because I think our current tooling is all around looking at the output logs from the E2E tests, and this is less about the percentage of coverage, I think, than prioritizing what tests to do next. So we might look through all of our add-ons and kind of prioritize which add-ons are used most often, and then through those add-ons, which API calls they use. So we can start to look at writing the tests for the things we use most first as we take this journey to 100% API coverage.
Is the proxy going to know where like which add-on a request came from?
I was thinking about ways to handle that. Because we're using an initializer that has access to the pod, we could inject some things there to identify which, because it's not enough just to do the token or the secrets. We really need to know what, possibly what container, and also what pod to bring that into the log, so we can sort this stuff by even within a particular add-on. Who's making those calls? That would be, I think that would be useful, that we're not going to get out of any logs currently.
And are you thinking this would be useful for something like GKE?
We're testing it on GKE because we figured that would be the hardest one to get all the information out of, since we don't have access to the API servers.
Okay, nice. And wait, so then how, so you're doing that with the add-ons talking to your proxy instead of, okay, interesting.
Yeah, so there's several ways we can do it. Currently we're doing it via an IP tables transparent target redirect based on the variable on the pod that says where the Kubernetes endpoint is. But a cleaner way we thought about is maybe updating the environment variable to point to a DNS or a service address, and then using a CSR for that service endpoint and running the proxy there. So no IP tables for that.
I think one thing that, you know, have you talked to Kenichi about, he's the main person who wrote the log analyzer, and I think there was some discussion around, you know, and I don't think there was a consensus, but there was varying opinions about whether we wanted to explicitly look at the calls that the tests were making versus, you know, calls that were kind of just randomly happening as a side effect of, you know, maybe I make a call here, which then has some other service which is part of the test. And so that would potentially give, like, you know, a different, you know, it would change the coverage metrics. And is that, I guess yeah, I mean, I guess you could sort of look at where you could sort of maybe group coverage by source to handle some of that.
I'm hoping that we can take it a bit further than just from the source node, but down not just to the pod level, but container. So if an add-on spins up multiple containers, that we would know which of those containers are making those API calls, just from a debugging perspective, really. But also, as you said, is this part of our test, or is this coming from random things that we don't need to intercept? If we do it at that variable level, we're able to affect just that add-on. Yeah, those are not all solved stuff yet, but I think it's solvable.
And so, so the IP tables that you're writing, those are on the nodes, I guess?
Yep, I can send a link to the initializer.
Okay. We
basically insert an IP tables rule targeting the IP address that's mentioned in the variable. And then we do that before the service mesh table. So it's really the first pre-routing rule. So we win. We get all that traffic. And it's at the pod level, really, I think, if I'm looking at it right, because we're initializing the pod. So that's global to the pod, but I still like the idea of changing that var to a DNS name for that test suite, maybe, so we can isolate it that way as well.
Yeah, I mean, that sounds fairly promising.
Cool. I just wanted to get enough feedback. I'm trying to see if I can ask for some funding to write it.
Yeah, I think I would certainly like, you know, if you want to toss a link to the design doc in the SIG testing Slack channel or something, I would like to take a look at it.
Brendan Burns may have written the initial outline for the high level, and this was us just digging in to see, is it possible, and what were some of the.
Yeah, sounds cool.
Thanks.
Cool. That's the only item we have on this agenda today. So unless anybody else has something you want to bring up, we are all going to go, say, 15 minutes. Not everybody all at once. Okay. Cool. Thanks everyone for coming.